Okay, for this first example, they're telling us that the integral from a to b is going to equal 8. So that's the blue region here. The blue region is going to equal 8. So this part right here in blue is going to give us 8. They want us to find the green region. That would be the integral from b to c. So we're trying to figure out this region right here. We'll put a question mark there. But we know that the integral from a all the way to c is going to give us 20. So if the entire thing is 20, what is this question mark going to be? Well, it has to be 12. If our question mark is 12, then we would get 8 plus 12 is equal to 20, and that is correct. So this is kind of like a real easy little puzzle here that we got to figure out. And if you understand the picture, it makes it really, really easy. All right, let's go to the next question. Okay, for this example, we're doing the derivative of a definite integral. But a definite integral is just going to be a constant. So when you do the derivative of a constant, you always get 0. So here's an example of it over here. We're doing the derivative of this integral, but this integral goes from 2 to 5. So the final answer is just going to be some constant. So we're really just doing the derivative of a constant. So the answer to this is just going to equal 0. Now, if you wanted to do it the long way, you could plug the number in and then do the derivative of the number. So we get sine of 5 to the 4th power times the derivative of 5. Then we do minus, and then we plug in the 2. Then we have to do the derivative of 2. Of course, this piece right here is going to give us a 0. And so is this piece right here. Also gives us a 0. So you just end up with 0 minus 0. So either way you do it, you're just going to get 0 for your final answer. Okay, let's take a look at the next example. Okay, for this one, if we do the integral from a to a, it says that there's no width, so our integral is going to equal 0. It would be like doing the area of a rectangle. If the rectangle had no width, you would get 0. So here's an example of it. The integral from 2 to 2. And it doesn't matter what the function is. The function can be anything. If you're doing the integral from 2 to 2, there's no width. So you're just going to get 0 for the answer. All right, let's move to the next example. Okay, this is just review, but we're just going to do the derivative of the integral. For this one, we're going to plug in the x, and then we're going to do the derivative of x. Then we do minus, and we plug in the 3, and we do the derivative of 3. Now the derivative of 3 is going to be 0, so this entire piece is going to become 0. The derivative of x is 1, so our final answer is just going to be sine of x to the 5th. That's it. Let's put a box around it. And this is just review. Let's do another one of these. Let's do this one, the derivative of the integral. It's basically canceling. So we're going to plug in the 3. It's going to give us cosecant to the 5th of 3. Then we got to do the derivative of 3. And we'll do a minus. Then we're going to plug in the x. Then we got to do the derivative of x. The derivative of x is going to give us a 1. So this piece is just going to be negative cosecant to the 5th. And because the derivative of 3 is just going to be 0, this whole piece is going to give us 0. Final answer, we're going to get negative cosecant to the 5th of x. We can put a box around it. That's our final answer. All right, let's go to the next question. Okay, we've already done one like this, so we're just doing another example to kind of review. They give us capital F of x, and they want us to find f prime of 2. So we're going to start by finding f prime of x. And once we have f prime of x, then we'll just plug in the 2. To get f prime of x, we got to do the derivative of the left. That gives us f prime of x. And we also got to do the derivative of the right side. But this is giving us the derivative of an integral. So we're going to plug in the top. There we go. And we do the derivative of the top. And we got to put minus. Then we're going to plug in the bottom, which is e to the x. So we plug our e to the x in, and then we do the derivative of e to the x. Now the derivative of x to the 3rd is just going to be 3x squared. And the derivative of e to the x is just e to the x. So that's pretty much it. That's f prime of x. You can just stop right there. Or if you want to simplify this, you can simplify this. And you can also simplify this. The rule that we're going to use is when you have x to a power times x to a power, you have the same base, so you're just going to add the exponent. This is going to be 2 plus 3, so we're going to get x to the 5. Same thing if your base is e. You have e to the x times e to the x, you're going to get e to the x plus x. So that's kind of what we're doing over here. You bring the 3 down, but we have x to the 150 times x squared. So you add 150 plus 2, and you get 152 for the power. Same thing over here. E is the base. So we're just going to add 50x plus 1x, and that gives us 51x. Now we found f prime of x, but we got to find f prime of 2. So we still need to plug a 2 for the x. Now I'm just going to leave my answer like this because e to the power of 202 is really big, and so is 2 to the power of 152. Those numbers are too big. So let's just leave our answer like this. Even on the AP test, they would not want you to plug that in and get an actual number answer. That number would be so big that we would not be able to write it down on the screen. All right, let's go to the next example. Okay, we're going to do another review of one of these free response questions. This is the same one we did last time, but this time instead of finding the max, we're going to find the min. Finding the min is just a little bit harder, but it's not much harder. You'll see what's happening here. Keep in mind, question 1 asks for where, and question 2 asks for what. So what is going to be the y value, and where is going to be the x value. Okay, again, we're looking for the minimum for capital F. So here is capital F. If we do the derivative of both sides, we get that f prime equals little f. So little f is the graph. So we can replace the little f with capital F prime. Now that's important because if this graph is f prime, then it tells us how f is changing. When f prime is positive, f is increasing, and when f prime is negative, f is decreasing. Now, how much does f increase or decrease? Well, it's just the area under the curve. So the area here is 15, so capital F is going to increase by 15 from x equals 0 to x equals 5, and the area of the second region is 22, so capital F is going to increase by 22 as x changes from 5 to 11. So just as it says here at the bottom, our capital F is going to increase by 37. And because our third region is below the x-axis, the area for an integral would come out negative. So that means our capital F is going to decrease by that amount. So capital F decreases by 12. Now, what makes this one a little bit harder is that there are 2 possibilities for a minimum. The minimum could occur at the beginning, or the minimum could occur at the end. We just have to figure out which one is smaller. Of course, this is the absolute minimum. If it was a relative minimum, it could not occur at an endpoint. But for an absolute minimum, it can occur anywhere. I think you can see it's pretty obvious that the minimum occurs at the beginning because you go up 37, but you only go down 12. So the beginning value is actually 25 lower than the ending value. Remember, it's supposed to be x equals for your answer. So we're going to say when x equals 0, capital F has an absolute minimum value. Now for question 2, they don't want to know where the absolute minimum value occurs. They want to know what is the absolute minimum value. So for this question, we have to take our answer from question 1 and plug it into the capital F function. So when x is 0, you're going to put a 0 on the top here, and that would give you the integral from 0 to 0, and we don't even have to look at the graph because it doesn't matter what the function is. When your integral goes from 0 to 0, the answer to that integral is just going to equal 0. And it's not because the value is 0, it's because the value is the same. Whenever you have the same value for your integral, that integral will equal 0. So the absolute minimum value is equal to 0. Let's go to question 3. Now for question 3, this is exactly the same as we did last time. We're trying to find where g is concave down. So just to review, g is equal to this integral, and when we do the derivative of both sides, we get that g prime is equal to little f. So that means the graph of little f over here is actually a graph of g prime. So we can rename it as g prime. Now if we have a graph of g prime, how do we get a graph of g double prime? Well, we're going to have to do one more derivative. So we need the derivative of g prime. Now the derivative of g prime is the same thing as the slope of g prime. And you can see I've already written the slope of g prime above each line. So in the beginning, the slope is 2/5. From 5 to 10, the slope is 0. From 10 to 12, the slope is -4. And from 12 to 17, the slope is 4/5. So that is the second derivative. Now we need to know where the second derivative is negative because we want to know where g is concave down. The only interval where g double prime is negative is from x equals 10 to x equals 12. So that's going to be our answer. And you can write it in either format. The first one does kind of look like a point, so I usually prefer to use this notation here. Now that we've written the second derivative above each line segment here, it's going to be really easy to figure out where our second derivative changes either from negative to positive or from positive to negative. That's what it's asking for here. It wants to know, where does g have inflection points on the interval from x equals 0 to x equals 17? So we need our second derivative to change signs, either from positive to negative or from negative to positive. So this is an easy one. And if you saw our last video, the answer is going to be exactly the same. It's going to be at this spot right here when x is equal to 12, because that's where our second derivative changes from negative to positive. So we're going to go with x equals 12 for this answer. So this question is exactly the same as last time. Okay, this one's a little bit different. We're going to go ahead and find the formula for g on the interval from x equals 0 to x equals 5. Remember, this graph is g prime, so we're going to find the equation of this line, and we're going to call it g prime. Equation of a line is pretty easy. You need to find the point, you need to find the slope. We know the slope is 2/5, so you can put a 2/5 right here. Then you can plug in your point. It would be 0 for x, put a 0 here, and put a 2 for the y. If you do that, you can figure out that b is going to equal 2. So you put a 2 for the b, and of course our slope is 2/5. So it's pretty easy to find the equation of a line. Remember, this graph is g prime. So we've come up with the equation for g prime on the interval from x equals 0 to x equals 5. But we need to find the formula for g. So we have g prime. The way we're going to get g is by doing the integral. So let's go to the next page. Again, this is the equation of g prime that we just came up with. We do the integral of both sides. We're going to get g on the left. And on the right side, we're going to get the integral with a plus c. So we're going to have to solve for this plus c, which means we need a point. And you cannot use a point from g prime. This graph is the graph of g prime. Remember, we renamed it. Instead of being called little f of x, we're calling it g prime of x. Now, one of the biggest mistakes that students make is they plug a point from g prime into the equation for g in order to solve for the plus c. And you cannot do that. You'd have to plug in a point from g. So we have to look at the original function that was called g. G was equal to an integral. So we need to plug in a number from x equals 0 to x equals 5. Now, I think the easiest number to plug in is 5, because then we have the integral from 5 to 5. And that's the same number, so we would get 0 for the answer. So that means for the g function, we would have the point 5, 0. And that's the point you can use to plug in and solve for your plus c. Plug a 5 for the x. That would give you 25 over 5. So that's just going to be 5. And then over here, we plug in a 5 and get 10. We also have to plug in a 0 for the y. We plug a 0 for the y. The y in this case is kind of like your g. That will help us solve for c. You would get 0 is equal to 15 plus c. So you subtract 15 from both sides, and you get c is equal to negative 15. And now we're done. We know our c is negative 15. So we now have the formula for g of x on the interval from x equals 0 to x equals 5. All right, let's put a box around our final answer. And now we're done.